in simulation, I want to talk about our homework 1 first. I think all of you have already received the grading of homework 1. If you get 2 points, that means you are doing great. If you get more than 2 points, you are more than great. Okay? But I want to analyze this homework 1. I want to talk about the train of thought, which is the way of thinking. How do you solve this problem? How do you get the examples? An intuitive way is to list all the transportation phenomena and try to see if each of them is related to the law of large numbers. But this method is not a good search method. It's kind of brute force or naive search. And in order to think it, to answer this question in a more effective way, I think it should be like this. First, let's see what the law of large numbers is. Apparently, the law of large numbers should have a large numbers, right? A lot of things. But something behind it is was not mentioned in my lecture. I just posted a figure in my lecture, and that didn't explain the nature of the law of large numbers. So I was hoping that you could check the wiki, Google, or your textbook to see what this law is. Okay? If you check it, you will find that the law of large numbers actually means you have a large number of random variables, and all these random variables are IID, independent and identically distributed. Okay? So if you have a lot of large numbers, random numbers or random variables, but they are independent, or they don't follow the same distribution, then it will be illogical for you to use that as an example. Okay? So what in transportation, what phenomenon has a lot of numbers involved? For example, a network, a road, or a segment. The infrastructure doesn't involve a lot of large numbers. You only see a large numbers when you are talking about vehicles, because there are a lot of vehicles traveling on the network. So that's one possibility. You talk about something that's related to so many vehicles, and the vehicles number is a large number. Another possibility is you look at one entity, but you look at it over a period of time. For example, every day. And this will become another source of large numbers. Okay? So this is the train of thought, or the way of thinking. And if I think most of you have already given me very good answers. But I want to point out 2 novel examples. The first example is the number of tickets that a cop gives every day. So I think it's a very interesting example. And do you understand that? So a cop is giving out tickets every day, but this number of tickets is following a certain distribution. And if we follow a certain distribution, then we can use the law of large numbers. Another example will be traffic assignment. This is an example that is very difficult to express, to formulate. And the person who talked about this didn't formulate that well. So in terms of an origin and then a destination, we have several paths to choose. And our observation is most of the people are using the shortest path. But how can this be formulated by the law of large numbers? To be clear, I use this kind of formulation, so hope you can understand it. So I categorize the path into 2 categories. The shortest one and the others. And if I use 0 to indicate the shortest path and use 1 to indicate other path, we can have a distribution or ratio or 2 numbers. So A and B. A indicate a portion that is using shortest path. B is indicating another portion that's using other path. And A plus B will be equal to 100%. So we have only 2 choices in this discrete distribution. And by this formulation, we can get an expected value, which is equal to A multiplied by 0 plus B multiplied by 1, which is equal to B. Okay? And by this formulation, we can then use the law of large numbers. So with the number, if we assume that this is true, then when we get more and more data points, I mean the trip choice or path choices, we can finally reach to B. Okay? So this is the formulation. Do you have a question about that? And the next time, please name your file, PDF file, as first name and number, homework number.pdf for my convenience. Thanks. For example, if I want to submit one, it will be Shan 1 or Shan 2 or Shan 3.pdf. And don't give me Word files, just give me PDF. And half of you submitted by email and half of you submitted by digital Dropbox. So next time, please all submit by email. Okay? So this now is the topic of today, the methodology. In the methodology part, actually, I want to talk about how you prepare to do a simulation project. This is a table or Gantt graph for the procedure of simulation project. It has 7 stages: project scope, data collection, developing base model, and error checking, calibration, alternatives analysis, then final reporting. This is like a waterfall. This looks like a waterfall, right? So it's called a waterfall model. It's a traditionally used model. But I just want to talk about the first stage, project scope. And we can call it the requirement stage. Okay, the requirement stage. Understanding the requirement is very important. Here I borrowed a figure from software engineering. This figure means how much effort you have to spend when you try to fix something. For example, at the requirement stage, if you find something wrong, you can fix it. And so if we suppose the cost to fix it at this stage is 1, then as the time passes by, for example, in the deployment stage, which means the users have already received the product, then you have to spend 80 times the cost to fix the 1 bug. So that's why the requirement is important. And here is a figure that is reported by a company called the Standish Group in 2004. They investigated thousands of IT projects. And this portion means, and this bar means 3 kinds of projects that are affected by incorrect or improper requirement. So in 1994, if your requirement stage has something wrong, only 16% of the projects will succeed in the end. And 31% actually failed, and 50% were severely challenged. And this actually, the situation went better from 1994 to 2004, but the proportion of challenged and failed are still very big. So let's summarize. I want to give you some tasks we want to do at the requirement stage. The first task is to understand the concept. The second, I'm going to talk about them in more detail. I will just read them to you now. So distribute responsibilities, select the proper tools, define the scope, and plan for data collection, estimate the cost, and make a schedule. So let's talk about them one by one. And here is a very good figure I want to share with you. It shows how brainstorming plays its role in a project. So in the beginning, you have a lot of ideas, and after each stage, mean, at each stage, the ideas are filtered by the restrictions, and finally, you get the best idea. Okay, so it's very important for you to get a lot of ideas in the beginning, which is at the requirement stage. Task 1, understand the concepts. Understanding concepts is very, very important in simulation project. For example, we want to collect data, right? And Adele had a failed project because he asked somebody to collect data, and people went to collect data. And after the person came back, Adele found that the data collected were not the data he wanted. Because the data collector, didn't clearly understand what he wanted, what he should do. So, understanding the concept is very important. And for this class, especially for this class, there are some of you who are not in the field of transportation. And I posted this file online. It's the chapter 5, glossary, in Highway Capacity Manual 2000. And I hope you can read it in your spare time. So if you don't know many about transportation, please read it carefully to know how to correctly express every concept. Okay, this will be used. This will be tested in the midterm. Okay, this reading material is important. I don't need you to remember everything, but be familiar with it. And please discuss with your classmates or discuss with me about any term you couldn't understand. Okay, now I quickly go to task 2 for distribute responsibilities. Here is a comic I really like. This shows how the teamwork, why the teamwork is important in a project. Okay? I don't think you have any difficulty understanding this, right? So that's how 3 persons as a team can pass a gap here. So this picture depicts the importance of teamwork. And I want to mention 3 things for teamwork. 3 tips. First, make sure everyone has clear goals. Second, make sure each one has all accessible resources. Okay? And the third thing is, make sure everyone has already have adequate training. So these are 3 tips I want to talk about task 2. The third task is the focus of today, which is to select the proper tools. If you want to do a transportation project, you have a lot of types of tools to choose. The first one is called sketch planning tools. The second type is called highway capacity